Yeah, hi all. So this is one more question to find the nth order differential coefficient of the function y. Okay, yeah, so let's see. If log y is equal to tan inverse x, then find the value of y3, y4, y5 at x equal to 0, which means we need to find the differential coefficient of y3, y4 and y5 at x equal to 0, which means to say we need to find the third order derivative, fourth order derivative, fifth order derivative at x equal to 0. So what we will do, we will use our normal approach. First we will find the first order derivative y1, then second order derivative y2, and then we will apply Leibniz rule. And once we get the Leibniz, once we apply the Leibniz rule, we will get an equation with yn plus 2, yn plus 1 and yn, and then we will replace the value of n to get the y3, y4 and y5 at x equal to 0. Okay, so let's start with whatever is given. So they have given log y is equal to tan inverse x, so therefore let me write as it is. Okay, log of y equal to tan inverse x. Let me call it as equation number 1. I need it because I need to substitute the value of x equal to 0 to find the value of y of 0 here. Okay, so now log of y is equal to tan inverse x. So this implies that 1 by y into derivative of y, that is y1 will be equal to 1 divided by 1 plus x square, that is differentiating with respect to x, right? So this will become y1 will be equal to y divided by 1 plus x square. Call it as equation number 2. Okay, so now we have y1 is equal to y divided by 1 plus x square. Now I will cross multiply this 1 plus x square to this side, so that will become 1 plus x square into y1 will be equal to y. Okay, now I will apply the product rule here. So differentiating again with respect to x, what happens? First function into derivative of the second function, that will become y2 plus, now the 1 plus x square derivative will become 2x into the second function, I will keep it as it is, that will be equal to y1 will be equal to derivative of y is y1, right? This implies 1 plus x square into y2 plus 2x y1 minus y1 will be equal to 0. Let me call it as equation number 3. So now what I will do, so I have got a second order derivative 1 plus x square y2 plus 2x y1 minus y1 equal to 0. It is equation number 3. So now let's apply the Leibniz rule to this expression. Okay, so what happens? So that will become 1. I am writing it directly because we have solved many of the thing, so I am not writing nc0, nc1 and all. Okay, 1 plus x square into yn plus 2 plus n into the derivative of 1 plus x square is 2x and yn plus 1 plus we need to take the derivative of 2x, which is 2, so n into n minus 1 into n minus 2 factorial in the numerator and denominator will get cancelled. So that will be the derivative of 2x is 2 into yn. So the first term Leibniz rule we have applied, plus 2 into 2 I have taken a common outside, so we will apply the Leibniz rule to this xy1. So that is x into yn plus 1 plus n into the derivative of x is 1, so n into yn minus the derivative of y1 is yn plus 1 will be equal to 0. So let's further simplify this. So that would be equal to 1 plus x square into yn plus 2 plus this will become 2nx into yn plus 1. This 2 factorial and this 2 can be cancelled, so this will become n square minus n into yn. Let me open the bracket here, so this will become 2x yn plus 1 plus 2 into n yn will become 2n yn minus yn plus 1 will be equal to 0. Yeah, so that is 1 plus x square into yn plus 2 plus, so if we see yn plus 1 term, yn plus 1 term, we can take it together. So 2nx, see here 2x yn plus 1 is there, and here it is, yeah, let me write it together first, yn plus 1 plus this 2x y1, I am just rearranging it, and this minus yn plus 1 I am taking this side, so whatever is left out is this one, n square minus n from this yn term, and we have here plus 2n. So plus 2n into yn will be equal to 0. So that is 1 plus x square into yn plus 2, plus from here I can take 2xyn plus 1 common outside, so this will become 2n plus 1 into x yn plus 1 minus yn plus 1 will be remaining here, minus yn plus 1. So if you see here, n square minus n plus 2n, so my 2n minus n will be n, so that is n square plus n into yn will be equal to 0. So again here yn plus 1 is common, so what I will do, 1 plus x square into yn plus 2 plus, so here what I will do is yn plus 1, let me take common outside, so this will become 2n plus 1 into x minus 1, everything is multiplied to yn plus 1 plus n square plus n into yn will be equal to 0. Okay, so this is the equation that we get after applying the Leibniz rule to this equation number 3, and I will call this as equation number 4, which will be used to find the nth derivative of the function y. Number 4. Now we are asked to find y3, y4 and y5 at x equal to 0. So now let's start finding. In order to find y3, y4 and y5, let's try to put the value of x equal to 0 in each of this y1, y2 and so on, and then we will try to find the value of the differential coefficient. So in order to start, what we will do, let's first take the equation number 1. So what we have, log y, from equation number log y is equal to tan inverse x, right? Now let's keep putting x equal to 0. When put x equal to 0 implies log of y of 0 will be equal to tan inverse 0. Tan inverse 0 is 0 itself, so this implies that log of y of 0 will be equal to 0. I can write log tan inverse of 0 is 0. I can write it as log 1 also, right? Because log 1 is also 0. So what this implies that y of 0 will be equal to 1. Log y of 0 equal to log 1, which implies log y of 0 will be equal to 1. So this I have taken from equation number 1. Now I will do the same thing in equation number 2. Put x equal to 0 in equation number 2. What happens? So this implies that y1 of I found y of 0. Now I am finding y1 of 0 will be equal to y divided by 1 plus x square. So that is y of 0 divided by 1 plus x square is there. That is 1 plus 0 square. That is 1 plus 0. That will be equal to y of 0. We just found it as 1. So that is 1 divided by 1, which implies y1 of 0 is also nothing but 1 only. Okay, y of 0 is also 1 and y1 of 0 also 1. So now again put x equal to 0. Put x equal to 0 in equation number 3. That is here. That is to find the second order derivative. Okay, so now see, 1 plus x square into y2 plus 2 into xy1 minus y1 equal to 0. So what happens? So when I'm let me rewrite it here, 1 plus x square into y2 plus 2 into xy1 minus y1 equal to 0. This implies, let me replace x by 0 here. So 1 plus 0 is 0, so that is y2 of 0. Okay, so this term 2 into 0 into y1, this term will completely become 0. This y1, let me move it to the other side, so minus y1 will become plus y1. So that will be equal to y1 of 0. What is y1 of 0? We just found it as 1. Okay, this implies that y2 of 0 is also nothing but 1. Okay, so y of 0, y1 of 0 and y2 of 0, all the three y0, y1, y2 at x equal to 0 is 1 itself. Now we need to find y3, y4 and y5. In order to find y3, y4 and y5, what we need to do is we need to put x equal to 0 in our expression that we found using the Leibniz theorem. That is, put x equal to 0 in equation number 4. Okay, when we put x equal to 0 in equation number 4, what happens? That is here. Okay, so if you see here, 1 plus x square, that is 1 plus 0 square into yn plus 2 is nothing but just yn plus 2 plus 2n plus 1 into x. Here when I write when I write here 0, so this complete term will become 0, that is 2 into n plus 1 will become 0, so minus yn plus 1 will remain here, plus n square plus n yn will be equal to 0. So that implies that is 1 plus 0, that is x equal to 0 in equation number 4. What happens? 1 plus 0 into yn plus 2 plus this complete term will become 0, that is 0 minus 1, 0 minus 1 into yn plus 1. I am writing it as it is, yn plus 1 plus n square plus n into yn will be equal to 0. Okay, now this implies we need to find yn plus y of 0. So let me write it like this, will be equal to this 0 minus 1 is minus 1, so when I move this to that side, this will become yn plus 1, this n square plus n yn, when I move to that side, it will become minus n square plus n into yn will be equal to 0. Okay, let's call it as equation number 5. Okay, now we need to find y3, y4 and y5. So if we observe here, if we have to find y3, I have to put n equal to 1 here, that is 1 plus 2 will become 3, that is y3 of 0. So what, let's put, so let me rewrite it here. So what happens? Yn plus 2 of 0 is nothing but yn plus 1 of 0 minus n square plus n into yn of 0, right? So now I need to find y3. So in order to find y3, I have to put n equal to 1 here. So put n equal to 1. This is equation number 5, right? Put n equal to 1 in equation number 5. What happens? That is y3 of 0 will be equal to, so that is n plus 1. I mean n plus 1. That is 1 plus 1 will become y2 of 0 minus n is 1. So 1 square plus 1, n square plus n is 1 plus 1 into what is yn is that nothing but y1 of 0, right? y1 of 0, that is equal to y2 of 0, y0 and y1 and y2, everything we found it as 1 itself. So this is 1 minus, okay, 1 plus 1 will become 2 into y1 of 0 is also 1 only, so that will be equal to 1 minus, that will be equal to minus 1, right? So which implies y3 of 0 is equal to minus 1. Okay, now we have to find y4 also. In order to find y4, what we should do? Here yn plus 2 is there. If we replace n by 2, it will become 2 plus 2 is y4. So again put n equal to 2 in equation number 5. What happens? This replace n by 2, so this will become y4 of 0. y4 of 0 will be equal to n plus 1, that is 2 plus 1, that is y3 of 0 minus n square plus n. N square plus n is 2 square plus 2 into yn of 0. Yn of 0 is nothing but y2 of 0. Okay, so that will become, what is y3 of 0? y3 of 0 is minus 1 minus 2 square is 4, 4 plus 2 is 6, right? So 6 into what is y2 of 0? y2 of 0 is also 1. We found y1, y2 and y is 0, 1 itself. So that will become 1. That will be equal to minus 1 minus 6, which is nothing but minus 7. Therefore y4 of 0 is nothing but minus 7. Okay, so we found y3 and y4. We are left with y5. So in order to find y5, what we should do? In order to find y5, here see yn plus 2 So if this term has to become 5, we have to put n equal to 3. So put n equal to 3 in equation number 5. What it will give? Y here. So what happened? So 3 plus 2, that is y5 of 0 will be equal to y4 of 0 minus see 3 square n square plus n will become 3 square plus 3 into 3 square plus 3 into y3 of 0, right? That is y3 of 0. That will be equal to y4 of 0, we just found it as minus 7 minus 3 square is 9 plus 3 into what is y3 of 0? y3 of 0 we found it as minus 1, right? So that is equal to minus 1. That will be equal to minus 7 into minus 9 plus 3 is 12 into minus 1, right? So that will be equal to minus 7. Minus into minus will become plus 12. So minus 7 plus 12 is nothing but 5. So y5 of 0 equal to 5, which is the required answer. So it was asked to find y3, y4 and y5. So y3 of 0 is minus 1, y4 of 0 is minus 7 and y5 of 0 is 5. So every time whenever they ask us to find the differential coefficient of the derivative of function for a specific order, so what we have to do, first we have to take the y of 0, y1 of 0 and y2 of 0 initially. Once we get y2 of 0, then apply the Leibniz rule and get the equation using the Leibniz rule with yn plus 2, yn plus 1 and yn. So once you get that, the questions might be, they might ask you to find y3, y4, y5, or else they will ask us to find the yn of 0, the expression you might have to deduce. So every time you need to do like this, okay? Always y1 find y0, y1 and y2, and depending upon the whatever the equation you get, so you might have to replace n equal to 1, 2, 3, 5 now to find a y3, y4, y5 like this. Okay, so this is the answer. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.